Hello viewers, welcome back to the course on matrix computation and its application. So now we'll continue with that previous problem that we started in the previous lecture, that how we can write a matrix corresponding to the linear transformation related to the new basis. So we'll continue with that one. So in the previous lecture we have showed that how we can write the matrix corresponding to the linear transformation that is given to me in terms of standard basis and in terms of the new basis. Now, so basically what we are doing here, that suppose I have this is my vector space U and this is my vector space V. Now here for a given x, I am taking the linear transformation T, and this vector in the V, that is my Tx. Now from here I am able to write the matrix for T corresponding to standard basis, and this is equal to my Ax. So this way we can write directly from here, and this is what we have done here with this A. Now what we have done, the same vector I am taking, now I am writing this vector as a new coordinate of this vector with respect to the basis B1. So the same element, but I am writing a new vector, new coordinates of this vector x with respect to the basis B1. So basically here it is equal to x, and not equal to x, the new x it is coming. So whatever the coordinates will come from here, I am going to get Tx, that is in the V. So I am writing the coordinates of this with respect to basis B2, and then we know that we are able to write the matrix. So this matrix is my C matrix. So this will be equal to C and x of B1. It means that you take any transformation, any matrix, this transformation, linear transformation T, it is mapping the same element into the same element. The image of x will be Tx, does not matter which basis I am taking, because every time I am representing the same vector x with a new coordinate vector, and here the same thing is happening. So this is the relation between that, how the matrix will change with respect to the new basis. So let us verify this one. Now this is my matrix C, and this is the corresponding matrix. So let us take this one. Now for the continuing with the previous example. So from here I get my matrix A. So this matrix A was 1 to 1. Okay, so 1 to 1, minus 1, 3, 1, and 1, minus half, and minus 2, and I got matrix C, that is 2, 0, 1, 6 minus 3 by 2 and 11 by 2, 6 minus 3 by 2, 11 by 2, and 0, minus 1 by 4 and minus 5 by 4. So this is my new matrix corresponding to the new basis. So, this is I can write as a T with basis B1, B2. Now, so I want to check that. So, let I take a vector. So, I take a vector x as, suppose I take it 1 1 1. So, just take a simple vector 1 1 1. Now, I want to find its image. So, T x I want to find, that is I want to find what is the T 1 1, and this will be definitely, I know that this will be equal to A into 1 1 1 vector, and if I have this value, so it is 1 2 1 minus 1 3 1 1 minus half minus 2 1 1 1. So, from here it is 1 minus 1 and it will be 1 here. So, 2 plus 3 5 minus half, it will be 9 by 2, and it is 1 plus 1 2 minus 2. So, it will be 0. So, this is the image of this vector x. So, that is the image. So, this is the image, and this is basically equal to T x that I have taken from here. So, this is my A and this is my x. So, I have got this value. Now, I want to check that whether I am going to get this value with respect to the new basis also or not. So, this one what we need to do is that I have to verify this relation. So, what I am going to do is the same x I am taking now, and I am writing in the basis B1. Now, if you see from here, the basis B1 is, again we have taken, just for the simplicity, we have taken as a standard basis. So, I think it is not going to change anything here. So, the coordinates will be same 1 1 1, no problem. So, this is I have taken now. Now, from here, so this is the value, the T B1 I have taken. Now, I want to find the value corresponding to this. So, I want to find the left hand side, this one. Now, T x with respect to B2. Now, T x was what? T x is this one. So, I want to write the coordinates of this vector, coordinate of this vector with respect to the basis B2. So, how we can find? So, let us suppose it is equal to A B C. Now, from this one, and B2 is the matrix. So, this one I can write from here that my matrix C is this one. So, it should be equal to matrix C and then the vector A B C, that should be equal to 1 9 by 2 0. So, it should be 1 9 by 2 0. So, I can take the linear combination of these vectors, and I know that C is a 3 by 3 matrix which is invertible. So, from here I can find the value of A B C, and this will be equal to C inverse and 1 9 by 2 0. So, this one we can write, and if we solve this one, so that we can solve easily, we will get that the A is coming 8, B is coming minus 7 by 4 and C is coming 21 by 4. So, this value is coming. So, now from here I can say that the coordinates of T x, so T x the coordinate with respect to B2, that is the coordinate of 1 9 by 2 0. So, this is the my vector. So, it is a column vector basically. So, I can write as a transpose with respect to B2 is 8 minus 7 by 4 and 21 by 4. So, this value is there, we are able to get. Now, I want to verify that whether the same value is coming for C into x B1. Now, I want to find what will happen C into x B1, because x B1 is the coordinate of the same x with respect to B1. So, x B1 is 1 1 1, no problem. So, now from here I can write my this is C, just a minute, I just want to check the matrix made up of, no, this is B basically. So, I have to just write here changing the, so C is this one and B is this one. So, B is basically made up of the bases, and that was my 1 1 0, 1 2 3 and minus 1 0 1. So, this is my basis matrix. So, basically we are not writing here C, it is B, basis matrix, it is B that we have taken. So, B is the basis that is basically made up of B2. So, this is a made up of B2, as we have already seen that I have taken the basis B2, and from the B2 I made this matrix this B. So, this is the B I am taking, and based on this B we are able to write this form, and from here it is my B inverse, and that gives the value. Now, I want to find out this. So, C is basically, this is 2 0 1, 6 minus 3 by 2, 11 by 2, by 2, and 0 minus 1 by 4 minus 5 by 4, and this value we are taking. So, it is 1 1 1, 1 1 1. Now, from here if you see, I will multiply this. So, it will be 8 and then minus 3 by 2 minus 1 by 4, and this is 1 plus 11 by 2 minus 5 by 4. So, if I calculate this, it is 8. So, it is minus 3 by 2. So, minus 6 by 4. So, minus 6 and minus 1 minus 7. So, minus 7 by 4, and this is 11 plus 2 13 by 2. So, 26 by 4 minus 5. So, it will be 21 by 4. So, you can see from here that this vector and this vector, so this and this are same. So, from here this is verified that the same x is going to the image T x. Now, in the new basis we are writing the same vector x with the new basis, and the image also we are writing with the new basis, and that is also equal to this one. So, that makes the verification for this one. So, this is the way we are writing the same linear transformation with respect to the new basis. So, let us take one other example, that how we can define this example. So, let us take one. I have a linear transformation T from set of polynomial of degree less than equal to 3 to the set of polynomial of degree less than equal to 2. So, where P3 is set of all polynomials of degree less than equal to 3 and P2 also. Now, from here I define the linear transformation T from alpha 0 plus alpha 1 x plus alpha 2 x square plus alpha 3 x cube, and that is equal to, we are defining as alpha 3 plus alpha 2 plus alpha 3 x plus alpha 0 plus alpha 1 x square. So, this is the image we are defining T from P3 to P2. Now, based on this one I want to write, so the question is find the transformation matrix of T relative to the basis. So, this is the basis we are going to take. So, we are defining the basis B1, that is we are taking 1 x minus 1 x minus 1 square and x minus 1 cube. So, this is the basis B1, and B2 we are taking standard basis 1 x x square. So, this is my linear transformation. Now, if somebody asks me that what will be the matrix corresponding to the standard basis, so we know that. So, now let us do directly from here. So, solution. So, we know that the linear transformation is completely determined by the image on the basis of P3. So, I will want to find out what will be the T of 1. So, T of 1 means, if you see from here, it means that alpha 0 is 1 and all other terms are 0. So, if you see from here, this will be 0, this will be 0, only x square will come. So, its image is basically x square. T of x minus 1. So, if you take from here x minus 1, so alpha 1 is 1 and alpha 0 is 0. So, x minus 1 implies that alpha 1 is 1 and alpha 0 is minus 1, and all other terms alpha 2 is 0 and alpha 3 is 0. So, this all will be 0, only 1 minus 1. So, that will be 0. So, it will be 0 in this case. T of x minus 1 square. So, T of x square plus 1 minus 2x. So, this is what we want to find out. So, from here I have my alpha 2 is 1, alpha 0 is 1, alpha 1 is minus 2 and alpha 3 is 0. So, if I substitute here, alpha 3 is 0, alpha 2 is, so now from here that value is going to be x square minus x, because x square will come from here and x will come from here. Alpha 2 is 1, it is minus plus. So, it is minus x square plus x. Now, the same T of x minus 1 cube. So, this will be equal to, so it will be x cube minus 3x square plus 3x minus 1. Now, from here you can say that alpha 0 is minus 1, alpha 1 is 3, alpha 2 is minus 3 and alpha 3 is 1. And if you put the sign here, so it is equal to x3 is 1 plus then x2 plus x3. So, x2 plus x3, so it will be minus 2 x and then x0 plus x1, alpha 0 plus alpha 1. So, it is 3 minus 1 plus 2, so 2x square. So, that will be equal to 1 minus 2x plus 2x square. So, that is the image. Now, from here we can write. Now, this is my standard basis basically. So, from here I can write this as 0 1 plus 0 x plus 0 into 1 into x square. So, from here if you see my matrix, I can write my matrix A, that will be, so it will be T of 1 with respect to basis B2, T of x minus 1, the coordinates of this one with respect to basis B2, coordinates of T of x minus 1 square with respect to B2 and coordinate of x minus 1 cube with respect to B2. So, this is I want to write, and that will be equal to 0 0 1 0 0 0 and then we have, now it is 0 1 minus 1 and this is 1 minus 2 2. So, it is 3 cross 4. So, that is the matrix we are going to get for this. So, that is my matrix for the linear transformation corresponding to the basis B1 and B2. So, that is my answer, because we are taking the linear transformation from P3 to P2. So, it is a dimension 4 and dimension 3. So, we are getting the matrix 3 by 4. Now, the same way we can define the another example. Suppose I have a transformation T from the vector space U to the vector space U, and let dimension of U is n. Then suppose I take this transformation T of x is equal to x. So, now if I want to write the corresponding linear matrix corresponding to the transformation, then if from here you can see that it is like Tx is x. So, I am having the transformation from this, that is my x, taking the transformation T. So, this is my Tx, but that is also equal to x. So, what I am going to do is that I am going to write the matrix. So, and x is belongs to U. So, definitely my x will be x1, x2, xn dimension, and this is also equal to x1, x2, xn, and this one I can write in the standard form. So, I can write my x1 as 1 0 0 0, x2 0 1 0 0 0, and in the end I can get xn, that is 0 0 1, and from here I can write a matrix. So, this matrix is 1 0 0 1 0 0 1 0, and in the end we will get 0 0 1. And if you see from here, then this is equal to x 1 x 2 x n. So, this matrix, if you see, then this is identity matrix of order n cross n. So, and also we know that this transformation is identity transformation. So, if we are writing the matrix corresponding to the standard basis, then you can see that this identity matrix gives us the identity matrix. This identity linear transformation gives the identity matrix for this one. So, this way we can write the matrix corresponding to the given transformation. Now, so after doing this one, the next question is that, so we are able to write the matrix corresponding to the given linear transformation. Can we do the another way? So, we want to do the converse of that one. So, we write down linear map associated with a matrix. So, now in this case we have a matrix A that is suppose of order m cross n, and from there I want to find the linear transformation T from U to V. So, dimension of U will be n and dimension of V will be m. So, this way we want to write that how we can write these things. So, let us see that how we can write the linear transformation from the given matrix. So, let's we have a matrix. So, I have a matrix A that is made up of LYJs of order m cross n. Now, then we can define a linear map or linear transformation as. So, how I can define? So, I can define by T from U to V, right. So, we can define the linear transformation T from U to V. So, now everything depends upon that what are the bases we are going to take. So, if there is no basis, then we can define that this is a standard basis. So, no problem, but let we have. So, let us we have basis B1. So, that is the basis we are taking, that is U1, U2, UN. So, this is the basis of U and B2. So, that is my V1, V2, Vm. This is the basis of V and this is the basis of U. Now, I know that how we can define the linear transformation. So, these are the ordered bases. Ordered basis of U and V. Now, I can define. So, now we can define the linear transformation like this. T of I will take u1. So, that will be equal to, now this is the matrix, corresponding matrix we have. So, this is the, and I know that this matrix is made up of the coordinates. So, I know that my A is basically T of u1 and the coordinates of this one, T of u2 coordinate this one, and T of un the coordinates of this with respect to B2. So, this is, I know that this is my A. So, it means that I have to write the first column. So, that first column will be alpha 1 1, it is V 1 plus alpha 2 1 V 2 alpha, and then we are taking it M 1 V m, because it is m numbers there. So, this is my first image. So, this is the way we can write down. So, same way I can write T of my un, that is alpha n 1 V 1 plus alpha n 2 n 1 n. This is 1 n V 1 plus alpha 2 n V 2 alpha m n V m, and this way we can find out the given linear transformation corresponding to the basis B 1 and B 2. So, let us take one example, and I know that this is the basis, these are the bases. So, here this T is unique, it is uniquely determined for corresponding to this basis. So, for example, let us take one example. I have a transformation. So, suppose I have a matrix A, this matrix is given to me, it is suppose 2 1 minus 2 1, it is minus 3 0 1 2 4 minus 1 0 minus 2. So, it is 4 cross 3. So, that matrix is given to me. Now, case 1, I want to write LT. So, write linear transformation corresponding to A relative to standard basis. So, I have a standard basis, then in that case I will just, so from here I know that my transformation T will be from U to V, where my, or maybe I can just write from here that T will be from V3 to V4. So, from here I can write that my matrix A taking the element from V3, that is x1, x2, x3. This will be equal to my T of x, because x I am taking x1, x2, x3 belongs to V3, and if you write from here, then I can write my A. So, image will come. So, I just multiply by x1, x2. So, you will find from here it will be 2 x1 multiplying this by the first row. So, 2 x1 minus 3 x2 plus 4 x3. This is the first component. Then x1 minus x3, then minus 2 x1 plus x2, and then x1 plus 2x2 minus 2x3. So, that is my linear transformation corresponding to the standard basis. Now the same linear transformation I want to write related to this basis B1 and B2. So, this is okay, means we are able to write very easily the corresponding linear transformation for the with respect to the standard basis. Now, we want to write the linear transformation corresponding to the basis B1 and B2. So, let me stop here today. So, in the today lecture we have discussed various example based on that how we can find out a matrix corresponding to the linear transformation with respect to the basis, and then we define the converse of that one, that we have a matrix and we want to find out the linear transformation corresponding to that one. So, in the next lecture we will show that how we can write the linear transformation corresponding to the basis, the new basis B1 and B2 as we are going through this example. So, thanks for watching, thanks very much.